Alrighty, friends and neighbors, welcome back. We are starting Volume 2 review, and this video will cover chapters 1 through 10 of the Do I Know This Already questions. Now, I decided to do something a little different. If you weren't sure which chapters you wanted to study, I'm adding this chapter topics list. Really, it's just the titles for the chapter. So, Chapter 1, Intro to TCP/IP, Transport and Applications. Chapters 2 and 3 sort of go together, basic and extended or advanced access control lists. And then we start into the section for security. So chapter 4 is security architectures, chapters 5 and 6, securing network devices, and then the vaunted switch port security. Chapters 7 and 8 also sort of go together with implementing DHCP, DHCP snooping, and then ARP inspection, also known as dynamic ARP inspection. And then chapter 9 was the device management protocols, and chapter 10, network address translation, which we know and love and use every day. Well, there you go. There's your topics. On to the Do I Know This Already questions. All right, friends and neighbors, welcome back to another networking video. We are working through our first chapter in Volume 2. So we're going to start with TCP/IP transport layer and applications. Now, there's a lot in this chapter. So in the show notes, I'm going to point to a whole bunch of videos that will help you with individual points on this if you want to go a little bit deeper. But for right now, we're going to cover what's in the chapter. Okay, that's a lot of stuff. Let's do the Do You Know This Already questions. Which of the following header fields identify which TCP/IP application gets data received by the computer? Choose two. Well, we know that in the client-server interaction, we're asking for the source and destination, IP addresses, source and destination, port numbers. But because this question had both TCP and UDP ports in there, there was no way to differentiate them, so those two are the correct answers. And this is the multiplexing that we get when we have data coming back to our computer. So D and E. Question number 2, which of the following are typical functions of TCP? Remember that we're talking about TCP here, not UDP, and TCP, that mother hen protocol, does all of these things: flow control, error recovery, multiplexing, ordered data transfer, right? Those sequence and acknowledgement numbers and the window size. Which of the following functions is performed by both TCP and UDP, right? So UDP doesn't have those advanced functions, but they both do that multiplexing using port numbers. Question number 4, what do you call data that includes the layer 4 protocol and data given to layer 4 by the upper layers, not including any headers and trailers from layers 1 through 3? Well, the language that we use at TCP is a segment, right? So you prepare a segment, and the sequence and acknowledgement numbers are all about the segments. And since we're talking about layer 4, it's a layer 4 protocol data unit, or PDU. In the URI example here, http://blog-certskills.com/configlabs, which part identifies the web server itself? Well, the answer that would come back from DNS would be the blog certskills.com. The rest of that is the path, and of course, HTTP is the protocol or scheme used. Question number 6, Fred, good old Fred, opens a web browser and connects to the certskills.com website. Which of the following are typically true of what happens between Fred's web browser, the web client, and the web server? Choose two answers. Well, because we're talking about HTTP traffic, we know that this is going to be port 80, and we know that this is going to be a TCP-based protocol. All right, friends and neighbors, welcome back to CCNA Volume 2, Chapter 2. We are going over basic IPv4 access control lists. So we'll do a bunch of examples, and I will include a whole bunch of content that is in other videos. But let's get started with access control lists. All right, did you know this already? Questions. Barney is a host with IP address 10.1.1.1. Hey, sounds familiar. On a particular subnet. Which of the following are things that a standard IP ACL could be configured to do? And the answer is that there were two things we could do. We could say, I want to match the particular source IP address, or we could do the subnet. We could do both of those with standard ACLs. Which of the following answers list a valid number that can be used with standard numbered ACLs? Well, with standard, right, remember that there are 1 to 99, and then there's that whole group above that. So the answers were 1987 and 87 were available. Question number 3, which of the following wildcard masks is most useful for matching all IP packets in a subnet 10.1.128.0 with a mask of 255.255.255.0? And the answer was D. We're going to match a whole subnet, or at least a whole class C address space, which is 0.0.0.255. Question number 4, which of the following wildcard mask is most useful for matching all IP packets with a subnet of 10.1.128.0 with a mask of 255.255.240.0? Now, I have this one asterisk because if you follow the rules of the chapter, then the answer would be E 0.0.15.255, but the key in the book says 0.0.0255. Question number 5, ACL 1 has 3 statements in the following order. If a router tried to match a packet sourced from an IP address 1111 using this ACL, which ACL statement does a router consider the packet to have matched? Well, we know the first match criteria. So if that logic says I match that first rule, then I'm going to take it. This rule right here, 1.0.0.0 0.255.255.255 matches everything from the one net. So the answer is A, the first one. Which of the following access list commands matches all packets sent from hosts in a particular subnet? But take a look at that mask. It's a /23. So the trick in this question was convert it to a base 10 mask and then see what you needed to do. So that would be 255.255.254.0. And so the corresponding wildcard mask would be B 0.0.1.255. All right, friends and neighbors, welcome back. We are moving through Chapter 3 in CCNA Volume 2, Advanced Access Control Lists, or what is sometimes called Extended Access Control Lists. Okay, the did you or do I know this already questions. Which of the following fields cannot be compared based on an extended IP ACL? Well, that was pretty straightforward. We know that it's source and destination IP address, protocol ID, the type of service or the DSCP bits, and then the port numbers. The URL and FTP file name are not part of those. Question number 2, which of the following access list commands permit packets going from host 10.1.1.1 to all web servers whose IP addresses begin with 172.16.5? And the correct answers there were A and E. They had the correct numbers for the extended ACLs, 1 to 199 or 2000 to 2699, and the syntax was correct, right? The fields were in the right order. Question number 3, which of the following access list commands permits packets going to any web client from all web servers whose addresses begin with 172.16.5? This is the same question earlier, but flopped around. So the only one that matched there was E. Again, correct number, right? 2000 to 2699, and then correct field orders. Question number 4, in a router running a recent iOS version, right? So that's 15. An engineer needs to delete the second line in ACL 101, which currently has 4 commands configured. Which of the following options could be used? Well, you could get rid of them based on the sequence number, like I just did, or you could kill off all of the ACLs and then put the ones back that you needed. Those are the only options in that particular question. Question number 5, refer to the following command output, which details an ACL enabled on port G0, 0, in the inbound direction, which answers lists a configuration mode and command that would result in the deletion of the line that matches 172.16.1.0. So this is the line that we're worried about right here, right? We could delete that sequence number right there. But if we also dropped into the named ACL, we could also use a very traditional no in front of the entire line, and that would do it as well. So that was C and D. And lastly, an engineer configures an ACL but forgets to save the configuration. At that point, which of the following commands display the configuration of an IPv4 ACL, including the line numbers? Well, we just did that, show access list or show IP access lists. All right, friends and neighbors, welcome back to CCNA Volume 2, Chapter 4, Security Architectures. All right, do you know this already? Which one of the following terms means anything that can be considered to be a weakness that can compromise security? Well, that was B, the vulnerability, right? An actual potential to exploit a vulnerability is known as which one of the following terms? Well, that would be a threat. You're vulnerable, but if nobody can take advantage of it, there's no exploit there. And then if they can, now we have our threat. In a spoofing attack, which of the following parameters are commonly spoofed? MAC addresses and source IP addresses are the most commonly spoofed items. Question number 4. Suppose an attacker sends a series of packets towards a destination address with a TCP SYN flag set, but no other packet types. Which of the following attacks is likely taking place? Well, this is the one that we talked about. This is a denial of service that's taking advantage of the TCP handshake behavior. Question number 5. In a reflection attack, the source IP address in the attack packets is spoofed so that it contains which one of the following entities? Well, in reflection attacks and amplification attacks, the destination will be the address of the victim because the attacker is just trying to send traffic to that victim via the reflector. Question number 6. During a successful man-in-the-middle attack, which two of the following actions is the attacker most likely to perform? Well, the whole reason for a man-in-the-middle attack is to do eavesdropping, so that was one. Now, the data modification part is the attacker has to complete the connection. So the attacker has to forward traffic between, say, the client and server. Question number 7, which of the following is the goal of a brute force attack? Well, brute force is exactly what it sounds like. I'm going to try this and try this and try this and try this until I find the right thing. So trying every combination of characters to guess the password. Which one of the following is an example of an AAA server? Well, that was the ISE, the security engine that Cisco uses, and that includes the TACX and the Radius AAA servers. Question number 9. Physical access control is important for which one of the following reasons? It prevents access to closets. All right, friends and neighbors, time now for Chapter 5 in the CCNA Volume 2, Securing Network Devices. All right, did you know this already? Imagine that you have configured the enable secret command followed by the enable password command from the console. You log out of the switch and log back in at the console. Which command defines the password that you had entered in the privileged access mode? And that would be enable secret. Question number 2. Some iOS commands store password as clear text, right? We saw that. But you can encrypt the password using the service password encryption global command. By comparison, other commands store a computed hash of the password instead of storing the password. Comparing the two options, which answer is the most accurate about why one method is better than the other? Now remember that the whole point of a hash function is to be easy to create the hash but hard to work backwards. And even if you did the service password encryption to get rid of the clear text, right, that is easier to decrypt than the hash function. So that was A. Question number 3. A network engineer issues a show running config command and sees only one line of output that mentions the enable secret command as follows: enable secret 5 and then that hash. Which of the following is true about the users of this router? Well, when you type in your password, you're going to type in the clear text password, hi there. And the router does the hash and then compares that to the hash that's stored. So that was B. Question number 4. A single line ACL has been added to a router configuration using the command IP access list 1, 172.16.4.0, and then 001.255. The configuration also includes the access class 1 command in the VTY configuration mode, which answer accurately describes how the router uses ACL1. So this was the indirection, so host in this subnet can tell that to the router. Question number 5. A next generation firewall sits at the edge of the company's connection to the internet. It has been configured to prevent telnet clients residing in the internet from accessing telnet servers inside the company. A wise choice. Which of the following might a next generation firewall use that a traditional firewall would not? And that was B, match message application data. So, right, that is the ability to look inside and see what's happening inside the packets and what actual commands or messaging might be there. Question number 6, which actions show behavior typically supported by Cisco Next Generation IPS beyond the capabilities of a traditional IPS? Choose 2. That was A and D, using host-based information, right? More information about the hosts, and filter URIs using reputation scores. So that was more details about the environment and getting contextual clues. All right, friends and neighbors, welcome back. We are tackling Chapter 6 in CCNA Volume 2, implementing switch port security, and we'll see exactly what that means in terms of modes and violations. So here we go. Do you know this already? Which of the following is required when configuring port security with sticky learning? Well, the first thing, as you saw, I forgot to do it. You've got to enable switch port security first, and then you can do whatever your options are. Number 2, a Cisco Catalyst switch connects to what should be individual user PCs. So those would be access ports, right? Each port has the same port security configuration, configured as follows. So there's the range command, everybody's been made an access, port security has been turned on, and then switch port security MAC address sticky has been enabled as well. So that means I'm going to learn whatever MAC address is there. Which of the following answers describes the result of the port security configuration created by these commands? Choose 2. That was B and D. Switch traffic is prevented, and it will not save addresses. Okay, so if you're in violation of the MAC addresses, then your traffic will be prevented. And as you saw, depending on which iOS version you're dealing with, that might actually be shut down. In the case of sticky, right, we have to also remember that those MAC addresses are not retained, right? The switch learned them, and in the same way that the switch SAT does not save that stuff, neither will the sticky MAC addresses be saved. All right, question number 3, which of the following commands list the MAC address table entries for MAC addresses configured by port security? There are 2 commands that will do it, B and C, show MAC address table and show MAC address table static. Now, the confusing part about that is that if you did sticky, they're kind of learned, but if you set up MAC addresses configured by port security, then they would have been static. So you could see them in a MAC address table command or in the static configuration. Question number 4, the show port security interface F0/1 command lists the port status of secure shutdown. Which of the following answers must be true about the interface at that time? Well, the state will be disabled or error disabled. And of course, the security state is secure shutdown. So we saw that when we were recovering. Question number 5, a switch's port gig01 has been correctly enabled with port security. The configuration sets the violation mode to restrict. So this is not shutdown, and this is not notify, right? A frame that violates the port security policy enters the interface, followed by a frame that does not. Which of the following answers correctly describe what happens in this scenario? So there's a couple of things, right? One is that a log message will be generated. A log message is generated for all of the modes, and the violation counter will be increased by 1 because one MAC address violated and the other one did not. All right, friends and neighbors, welcome back to another CCNA networking video. This time we are working on Volume 2, Chapter 7, Implementing DHCP. All right, our Did You Know This Already quiz. Question number 1, a PC connects to a LAN and uses DHCP lease on an address for the first time. Of the usual 4 DHCP messages that flow between the PC and the server, which ones does the client send? Well, we know that right off the bat. It's the discover and then the request after the server comes up with an offer. Question number 2, which of the following kinds of information are part of a DHCP server configuration? Well, we just configured that, so we know that we're going to give out the network or the IP addresses to lease, and then also the addresses not to lease. These are the excluded addresses. Question number 3, which answers list a criterion for choosing which router interfaces need to be configured as a DHCP relay agent? Well, we have to make sure that the subnet off of the interface has DHCP clients, but there isn't a server there. So that was A and C. Question number 4, a router connects to an internet service provider using its gigabit interface. With the IP address DHCP command configured, what does the router do with the DHCP learned default gateway? Well, we just saw that it adds a default route. In the following excerpt from a command on a Macintosh computer, which of the following parts of the output represent information learned from a DHCP server? Well, if we think about what we just configured and we think about the basics, we know that we need the IP address and the mask will have come from the server. All of this other stuff is interface specific or automatically figured out. Question number 6, which of the following commands on a Windows OS would list both the host IP address and DNS server's IP addresses as learned with DHCP? We saw that was ipconfig/all. All right, friends and neighbors, welcome back to another CCNA networking video. Today we are covering Chapter 8, DHCP snooping and dynamic ARP inspection. Now, as I go through this, we're not there yet, but we're getting near the end of this whole CCNA journey. So, hey, put in the comments down below maybe the next journey we ought to take. What's the next cert we ought to tackle? What's the next topic? But for right now, we're going to be doing DHCP snooping and ARP inspection. And speaking of the chapter questions, do I know this already? So an engineer hears about DHCP snooping and decides to implement it. Which of the following are the devices on which DHCP snooping could be implemented? Well, hey, this is all about layer 2 stuff. So switches and multi-layer switches can both do DHCP snooping and dynamic ARP inspection. Question number 2, layer 2 switch 2 connects to layer 2 switch 1. So 2 switches and a router, a DHCP server, and 3 PCs. All PCs are DHCP clients. Which of the following are most likely to be in the DHCP snooping trust state configurations on switch 2 for the ports connected to the listed devices? Choose 2. Okay. Well, since you don't know what's downstream of a switch, that might be a good place to trust because you might have a router downstream there or other servers. And of course, we already saw that PCs are not trusted devices. So those ports would be untrusted. The other devices were not options in the question. But as we saw, we would want to trust a DHCP server as well, if that was one of the answers. Question number 3, switch 1 needs to be configured to use DHCP snooping in VLAN 5 and only VLAN 5. Which commands must be included assuming at least one switch port in VLAN 5 must be untrusted? Choose 2 answers. Well, you've got to enable DHCP snooping globally, and then you've got to enable it on the VLAN. So that was C and D. Question number 4, on a multi-layer switch, a switch needs to be configured to perform DHCP snooping on some layer 2 ports in VLAN 3. Which command may or may not be needed depending on whether or not the switch also acts as a DHCP relay agent? Well, we saw that early on, right? If you don't run a relay agent, then you're going to want to ensure that you don't do the information option in the DHCP messages. So that would be, the command would be no IP DHCP snooping information option. If you didn't do that, or you just said IP DHCP snooping information option, that would be if you were going to use a relay agent. So that was A. I know it's a little confusing, but there's a difference between what a relay agent does to DHCP messages versus a standard DHCP server. Question number 5, a switch 1 has been configured to use dynamic ARP inspection with DHCP snooping in VLAN 5. An ARP request arrives on port gig 01. Which answers describe 2 items DAI always compares regardless of the configuration? So if you did nothing extra, right? If you weren't doing validation, what do you know you're going to be doing? And that would be, you're going to be comparing the MAC addressing that you see in the ARP messages against the DHCP snooping binding table. So that was the 3 PCs that we saw in the switch binding table. Question number 6, switch 1 needs to be configured to use dynamic ARP inspection along with DHCP snooping in VLAN 6 and only in VLAN 6. Which commands must be included assuming that at least one switch port in VLAN 6 must be a trusted port? Choose 2 answers. If you're going to do dynamic ARP inspection, you have to enable that on the VLAN. And then if you need to have a trusted port, you've got to go into a port and then say IP ARP inspection trust on this particular port. And last but not least, question number 7, a layer 2 switch needs to be configured to use dynamic ARP inspection along with DHCP snooping. No surprise. Which command would make DAI monitor ARP message rates on an interface at an average rate of 4 received ARP messages per second? Okay, so this is the rate limit question, but also the burst rate. So there were two answers in this particular question. One is if you just set a rate limit of 4. So if I got 4 messages in a second, that would be one, or if I got 16 in 4 seconds, that would be the same ratio. And so those two answers, C and D, were for question 7. All right, friends and neighbors, welcome back to Chapter 9 of CCNA Volume 2. And this time we are covering device management protocols, and in particular, syslog, NTP, CDP, and LLDP. All right, did you know this already? Questions. What level of logging to the console is the default for a Cisco device? We sort of saw that. It is D, debugging. The least worrisome messages that are out there is the default. What command limits the messages sent to a syslog server to levels 4 through 0? So that was the logging trap option. Now we didn't see that. We saw the option, but Packet Tracer didn't give me that granularity. But that is where you would set that with a logging trap level. Question number 3, which of the following is accurate about NTP client function on a Cisco router? That was A. The first thing that we do is synchronize with a server. And even if you were a server, you would talk to another server so that you could serve up clients. Question number 4, the only NTP configuration on router 1 is NTP server 10.1.1.1 command. Which answers describe how the NTP works on the router? Well, it acts as a server after it would synchronize with that server. Question number 5, imagine a switch connects through an Ethernet cable to a router and the router's host name is HANA. Which of the following commands would tell you information about the iOS version on HANA without establishing a telnet connection to HANA? Choose 2. So the first thing that you could do is show CDP entry HANA. Now, what we didn't go over, because Packet Tracer doesn't give us all of these details, so you saw the show CDP neighbor detail, and that tells you a lot of information about that. But on standard iOS versions, you can also specify an entry based on its host name or what it's been advertised. So the show CDP entry, HANA, is very specific to this particular node that's out on the network. Question number 6, a switch is cabled to a router whose host name is HANA. Which of the following LLDP commands could identify HANA's enabled capability? Well, this is just the LLDP version of the CDP things that we just saw. So show LLDP neighbors and then show entry HANA. All right, friends and neighbors, welcome back. We are doing Chapter 10 of the CCNA Volume 2, Network Address Translation. Something we all do. It's everywhere. Off we go. All right, do you know this already? Questions. Which of the following summarized subnets represents routes that could have been created for CIDR's goal to reduce the size of the internet routing tables? Well, there was just one answer there. That was the 210.0.0 network. And the reason for that is because this is a mask that aggregates. The other ones did not have a mask that aggregated. Question number 2, which of the following are not private addresses according to RFC 1918? B and E, 172.33 is outside that range, right? 172.31 would be the top, and then 191 is not in the address pool for the Class C section either. With static NAT performing translation for inside addresses only, what causes NAT table entries to be created? All right, so when you're doing static, which is what we did with the one-to-one mapping, the minute you have that, the translation is in the table automatically. With dynamic NAT performing the translation for inside addresses only, what causes the NAT table entries to be created? Well, since we're creating it on the fly, right, dynamic, we don't know what the traffic is going to be, so we have to see packets first. Question number 5, NAT has been configured to translate source addresses of packets for the inside part of the network. Makes sense. But only for some hosts as identified by an access control list. Which of the following commands indirectly identifies the host? Well, if you take a look at your access list, you'll get an idea for who is being translated. All right, question number 6, examine the following configuration commands, right? So here is an interface that's been given an IP address. It is the inside. And here is another interface that's been given an address and no designation of being outside. And then we've got our NAT command and then our access list. If the configuration was intended to enable source NAT overload, which of the following commands could be useful to complete the configuration? So in other words, what's missing? We needed two things here. And one answer was that we needed to do the outside, the NAT, IP NAT outside. So we got IP NAT inside, but not IP NAT outside. And then if we're doing dynamic NAT with this access list, then we could use overload right here. And our last question, number 7, examine the following show command output of a router configured for dynamic NAT, right? So this would have been show IP NAT statistics. Users are complaining about not being able to reach the internet. Which of the following is most likely the cause? Now, what we have to realize is that if you're doing network address translation, it's a problem for folks that are not being translated because they're using private addressing. And the outside internet would not know how to get back to those addresses. And so when we've got a whole bunch of misses, like this here, that means that the access list that we're using is not translating everybody. So that also means that the pool is not big enough to handle all of the addresses. So in other words, we've got this pool and access list combined that says I'm going to provide translation for a certain number of addresses. So in this case, the pool is not large enough. All right, so this has been the Do I Know This Already questions for Volume 2, Chapters 1 through 10. I hope this is helping you out on your journey. Don't forget those practice exams at the Prentice Hall site and all of the other resource material that's out there. Like and subscribe if I'm assisting you on your journey. May those packets always reach their destination. We're close, just one more review video. You can do this.